Imagine a world where the sky is not just a roof, but a door to the stars. A land where man discovered the secrets of the universe and harnessed infinite energy to power his world. It's not a distant dream, it's a reality beyond our imagination. Asterisk, when you wake up in the quiet morning, the first thing you notice is the gentle hum of the anti-gravity bed rising, watching you from the highest floor. Work, when you look out your window, the cityscape rises above the clouds, with cars flying like bees circling on arrival. As you enter the hall, your butler will greet you with a cup of tea made to your liking. You drink your tea and read the news on the augmented reality screen. You will learn that humanity has reached another milestone, a world that can harness the power of not one, but many stars in the galaxy. To the end of tea, you'll go to your transport pad and land at your workplace in the moonlight, a giant space station orbiting a nearby planet. Here, together with scientists and engineers, you will discover the secrets of the world and push the boundaries of human knowledge, and in the evening you will have an interstellar dinner. On a sleeper ship, you arrive at a distant planet known for its delicious food. You will be amazed by the skills of foreign chefs by trying dishes that challenge your mind. When you get home, you realize that this is just the beginning. There are many people, more and more wonderful than before. But how can I tell you that all these wonderful things are true? Perhaps some aliens have reached these levels of technological advancement. It all started in 1964, when Soviet scientist Nikolai Kardashev created a classification system, which grouped nations based on technological progress in energy consumption. Kardashev's scale ranges from Type 1 nations that have yet to fully utilize the power of the planet, to Type 3 nations that are able to harness the power of the entire galaxy. The interplay between energy and technology is important and underpins the progress of nations. As societies gain access to more energy resources, they develop new technologies and create a cycle that reinforces progress. Despite our progress, humans are still below the Kardashev scale, a proud Type 0. We have not yet harnessed all the energy on our planet or developed an energy infrastructure of the world. With a rating of 0.73 in 2018, our average electricity bill is 18.4 terawatts. Physicist Michio Kaku calculated that if we increase energy consumption by 3% per year, we will reach a Type 1 planet in 100 to 200 years. A Type 1 planet receives most of its available energy from its planet and nearby stars, receiving energy from fusion, fission, and renewable sources. They are capable of space travel, communication, planet building, and healthy progress with a single government throughout the solar system. But as Kaku said in Future Physics, even Type 1 civilization is disappearing. They have expanded beyond one planet, but great threats remain. Nations exercise power over the world by capturing the sun, manipulating volcanoes, controlling the weather, and building sea cities. This expertise in the natural world shows the real progress that occurs when the world reaches power and technology. But while the power of the first type of world may seem great, the second type of world will surpass them. Enter the Dyson sphere, a horizontal structure that rotates around a star to capture its energy. Although beyond our current technology, this idea raises questions about the use of interstellar energy by advanced civilizations. Consider the bright star Tabi, 1,470 light-years away, known for its curved moon patterns. Some say this is a product of Korea's Dyson. A Type 2 universe can harness unimaginable energy, manipulate the stars, and possibly create the energy of a universe and a black hole. These peoples can inhabit entire star systems, build homes, and even planets and moons. Beyond that, imagine a Type 3 universe, spanning an entire galaxy with stars and Dyson clouds. This race can manipulate energy and electromagnetic fields at speeds faster than light with unknown manufacturing technologies. A 2015 study suggested that although these races are rare, if they do exist, the galaxies would be their home, with only the planets as a deterrent. These objects can control stars, manipulate space and time, and extract energy from supernovae and black holes. Energy that cannot reach this level is said to take millions of years, if we survive that long. The lack of evidence for these tribes may not exist, as rapid development and advanced technology have obscured their presence. Although Kardashev originally argued for 3 types of worlds, some researchers suggest a Type 4 hypothesis that may be more active. These nations can explore a galaxy, harness the power of billions of stars, reorganize galaxies, and create new planetary systems.
Liftoff of
And so is the
Delta
concept
rocket
of the
carrying
multiverse.
JWST,
Imagine a
gamma-ray
world that
telescope
not only
searching
explores
for
other
unseen
worlds,
physics in the
but
stars
harnesses
of
their
the galaxy.
potential. A Type 5 universe can control infinite universes, manipulate hidden dimensions, and travel through time and space just as it would on our own universe. In the near future, humans may become a sixth type living outside of space and time, able to create and destroy entire universes at will. And Type 7 can create immortality, become pure superhumans, navigate pocket dimensions and travel through space. Turning to another perspective, consider ancient wonders like the pyramids. How did nations with limited resources fare so well? What if there is a level of technology beyond what we know, a level where they can touch the power of a star? This advanced society may have faced a crisis, a natural disaster, an interstellar war, or a change in space that forced them to leave their homeworld and discover the creations. Mysteries like the pyramids, Nazca lines, and underground cities. Left behind despite this evidence, we still cling to the idea that we are on top of the world. But what if we are just the latest in a long line of worlds rising and falling? As we stand on the brink of incredible technological potential, the question is whether humans will rise to the challenge or succumb to the pressures of our world. The transition from Type 0 to Type 1 means not only technological control, but a fundamental change in the way we view our planet, our resources, and our relationship. To the world that we are in a race against time,
Delta rocket carrying
a race to
JWST,
overcome the
gamma-ray
environmental,
telescope
social,
searching
and
for
political
unseen
obstacles
physics
that
in the
threaten our
stars
progress.
of the galaxy.
Climate change, resource depletion, and land instability are major challenges that can stop or reverse our journey to a more modern world. But there is hope. The road ahead. The advancements required to reach Type 1 are not confined to the realms of physics or engineering. They also demand profound social and ethical changes. For example, a unified global effort to develop sustainable energy solutions could bridge the gap between a divided world and a future powered by clean, renewable energy sources. Imagine a world where fossil fuels are a thing of the past and energy is drawn from vast solar arrays in space, wind farms the size of countries, and fusion reactors that provide virtually limitless power. A Type 1 civilization wouldn't be merely defined by energy consumption, but by the cohesion of its global society. Political borders would blur, replaced by planetary governance systems that emphasize collaboration over competition. Diseases that used to kill people were eradicated by medicine, and space exploration is still practiced today. The dream of interplanetary colonization is within our grasp. Depicting musical threats. However, getting to this point is problematic. Technologies that could take us back to the first type, nuclear power, artificial intelligence, biotechnology, are an ever-present threat. Any wrong action can have dire consequences, whether from environmental degradation, nuclear war, or the unintended consequences of the development of artificial intelligence. This delicate balance between harnessing the power of advanced technology and making sure it doesn't destroy us is perhaps the greatest challenge facing humanity. We need to develop not only the technical skills to move forward, but the knowledge to use those skills properly. Expanding our horizons. Looking to the stars, the goal of becoming an astronaut is much more than just a desire to explore. It is important for our long-term survival. The Earth, with all its beauty and blessings, is a fragile home. Asteroids, supervolcanoes, and even the slow death of the sun over the next billion years remind us that living on one planet is not a sustainable strategy. Colonizing other planets, from Mars and its moons to Jupiter and Saturn, is an important step in the survival of species. But it's not just about life. Global expansion fuels our passion and drives innovation to change the way the Earth lives. Imagine mining asteroids for rare minerals that could power our technology for thousands of years, or harnessing the power of distant stars to transmit information at the speed of light over great distances. These once amazing ideas can become a reality by stepping into the world's first world shoes. Working with extraterrestrials. Traveling to the stars raises another question. Are we alone in the universe? If Type 2 or Type 3 already exist, how do I contact them? Do they want to share their knowledge, or do they think that we are so small that it is easy to see? The possibility of meeting extraterrestrials requires us to prepare not only for technical challenges, but also for ideological and ethical challenges. How can we join the people who are millions of years ahead of us? Can we understand their technology and interact with them in meaningful ways? These are questions for the future, but the answers depend on the steps we take today. As we move up the Kardashev scale, our place in the world order becomes
Delta
clearer or
rocket
harder than we
carrying
thought.
GLAST, a gamma-ray telescope
The next
searching
leap,
for unseen physics
no matter
in the
how difficult the
stars of the
challenges
galaxy.
are, history shows that people can survive through adversity. The road to becoming a First Nation is full of hardships, but it's also a road full of amazing accomplishments. The technological advances we achieve not only change the way we live, but also the way we view the world and our place in it. The next leap for mankind will come from unexpected places. Advances in computing can unlock the world's mysteries, as can artificial intelligence is helping us solve complex problems faster than ever before. Cooperation between nations, rather than competition, is essential to advancing projects such as fusion energy, interstellar travel, and large-scale environmental restoration. Every step towards this future brings us closer to not only surviving, but flourishing as a species. Man's role in the universe on a large scale. Being a planet is just the beginning. It represents not only mastery over our world, but the ability to control our own destiny. We will no longer be under the protection of natural forces. We will be the guardians of the Earth, and maybe one day the guardians of entire star systems. But with great power comes great responsibility. As we move up the Kardashev scale, we must match our wisdom and moral growth to our technical skills. The tools we develop have the potential to reshape the universe, and the choices we make can determine the future of life across the galaxy. What will the future hold? Are we going to be astronauts, spreading life and knowledge to the far reaches of space? And are we going to be isolated from the needs of the universe? Will we meet other peoples, learn from them and become part of a global community? Or will we find ourselves alone, the first to begin this journey?